Hi guys, so we are starting chapter 5, which is rational numbers and equations. So in this chapter, we are going to identify and discuss rational numbers, integers, and whole numbers. We're going to write fractions as decimals and decimals as fractions, and we're going to add, subtract, multiply, and divide mixed numbers and fractions. So what is a rational number? A rational number is a number that can be written as a fraction or a ratio. So a fraction is a ratio, just written with a fraction bar. So the first question says, is 7 a rational number? So we think, well, can 7 be written as a fraction? Yes, we could think about that as 7 over 1. The next question says, is -3 1/2 a rational number? So this is a mixed number, which is a fraction, but if we wanted to write it as an improper fraction, we could write this as 7 over 2, -7 over 2. So would -7 over 2 be a rational number? Yes, because it's a fraction. Well, what about 1/3? Is that a rational number? Well, yes, it's a fraction. It's a special kind of fraction that's actually going to repeat forever, because if we think about 1/3 as a decimal, it's going to be 0.333 repeating forever. But since we can write 1/3 as a fraction, it is a rational number. So moving on to this picture. So this picture kind of helps us figure out where rational numbers fit in with the other kind of numbers that we've discussed, which are integers and whole numbers. So whole numbers is the smallest circle, and those are only positive integers, including 0. So those are just like the counting numbers. So 0, 1, 2, 3, 4, 5, repeating on forever and ever. Integers are a little bit different because they include positive whole numbers, but they also include negative whole numbers. So -1, -2, -3, and so forth. So all whole numbers are integers, but do you think that all integers are whole numbers? Well, the positive integers are whole numbers, but the negative integers are not going to be whole numbers. So no, all integers are not whole numbers. Then thinking about rational numbers are numbers that can be written as fractions. Well, all integers and whole numbers can be written as fractions. So that means that integers and whole numbers are rational numbers. So, terminating and repeating decimals. These are important because when we are converting fractions to decimals, there are two kinds of decimals that we can get. So when you divide two numbers, thinking about a fraction, so dividing the numerator by the denominator, the quotient or the answer will either be terminating or repeating. So a repeating decimal has a pattern that repeats and never ends. The way that we represent a repeating decimal is using a repeating bar like the one we have above 45 hundredths. So if we wrote 45 hundredths out without the repeating bar, we would keep repeating 45 over and over and over again, which if you see at the end, there's those 3 little dots. That means that the 45 will keep repeating over and over again. Terminating decimals end. So if we had the 45 hundredths without the fraction bar, that would be a terminating decimal. So any decimal that does not have a repeating bar over it is going to end eventually. So repeating and terminating decimals are rational numbers because they can be written as fractions. So what we're going to discuss in class tomorrow is how to write fractions as decimals and then how to change decimals to fractions. There are a couple of different strategies that we're going to talk about to change a fraction to a decimal. The first one is dividing the numerator and the denominator. That is one strategy that is always going to change a fraction to a decimal. But it's not always the easiest strategy. So thinking about our second strategy, it says scale the fraction up or down to have a denominator of 10, 100, or 1,000. Why do you think that it would be helpful to have a denominator of 10, 100, or 1,000? Well, if we think about fractions with those denominators, 10, 100, and 1,000, those correspond directly to place value. So if we think about a decimal that has one place value, that will be the tenths place. So if we think about a fraction 8 over 10, or 8 tenths, then we know that we're going to have an 8 in the tenths place. So if you can scale a fraction up or down to have a denominator of 0, 100, or 1,000, then that's going to be a really, really easy way to write the decimal. Another strategy we can use is we can simplify the fraction to benchmark fractions. For example, 6/12. If we wanted to write 6/12 as a decimal, we wouldn't want to divide, because that would be silly, because we know that 6/12 is 1/2, and then we know that 1/2 is going to be 0.5 or 0.50. The last strategy is to simplify the fraction, then divide. So for example, if we have a really big fraction like 100 over 154, if we simplified that to easier numbers to work with, then it will be a little bit easier to divide. So that is the last strategy. So what we're going to do tomorrow is we're going to convert fractions to decimals. We are going to write terminating and repeating decimals as fractions, and then we're going to order rational numbers from least to greatest. See y'all tomorrow.